malaria is pretty uncommon in the US. Almost 1 million people die every year. My aunt nearly died 2 years ago in southern India. The World Health Organization has been trying to eradicate for the last 3 decades. In countries like India, malaria is the 5th leading cause of death, and 90% of cases occur in hard-to-reach rural areas. Nearly 3 dozen point-of-care tests are on the market to help detect malaria. The problem with all of these tests are that they are qualitative, meaning that they only give you a yes or no answer. They don't tell if the levels of the malaria parasite are increasing or decreasing. Luckily, I heard about LAMP. LAMP is similar to PCR and uses a DNA loop structure to make self-propagating copies of DNA. This video shows more details about how it works. The main difference between LAMP and PCR is that precise temperature cycling is not needed. Unlike PCR, LAMP doesn't require heating and cooling cycles for it to work. My next steps were to figure out how to generate heat. I remember from my days as a Boy Scout about how to create warmth without a fire. I found a portable camping system that relies on an exothermic reaction. Anyone in the military would be familiar with the MRE, meals ready to eat. MREs are supplied with a small flameless ration heater, which require only a small amount of water. Once water is added, these small portable heaters can provide sustained heat for over an hour. To concentrate the heat, I embedded a small aluminum heatsink in a pool of beeswax. Beeswax serves as a phase change material and melts if the temperature exceeds 65 degrees Celsius. I needed to create the wax tray holder and chip holder myself, so I used 3D modeling software to make my designs and print them out on a 3D printer using heat-resistant filament. The chip holder holds the microfluidic chip in place right above the heatsink to achieve the right temperature. I designed the microfluidic chip myself and printed it out using a CO2 laser cutter. The chip contains 3 layers of acrylic, which I laminated together to direct fluid flow in the proper direction. The chip starts to change color in the presence of malaria DNA. The chip contains 3 separate wells for controls: low, medium, and high, and a 4th for the test sample. The color change can be detected by a smartphone app. I programmed and fine-tuned the app myself on the Android platform using Java. Here are some screenshots of the color change from the LAMP reaction. It was also important for me to compare how the LAMP reaction compares to a standard PCR. For this part of the experiment, I ran a quantitative PCR reaction in a genetics lab. It is now pretty clear that my LAMP system is just as sensitive as a PCR-based system to detect the earliest stage of malaria infection. With all of the materials, I estimate that one of my Malaria LAMP tests will cost less than $5. Thanks for watching.